All right. So the topic of this lecture is inequalities. So you guys might have detected that there's kind of a prevalent theme of this class. The way I'm teaching it, I kind of like the prevalent theme of this class to be truth. And just understanding what algebra really is, understanding that algebra is a language, and understanding the process of converting information into algebra language, and then using that to create equations that can then be solved. And like I said, truth is very important in this. For example, if we have something like this, we're learning what variables are, how to use them, and learning about operations of variables. Oh, looks like Miriam is joining us. I'll admit her right about now. And we know that this only has one solution. We know that x has to be 2. So we know that if we have this equation and we say x is 3, this is not true. This is false. There's only one correct answer, and it is this one. Algebra is very much concerned with truth. This one has only one true answer. Inequalities are a bit different, though. They're similar to equations in some ways and different in other ways. An example of an inequality would be something like this. X has to be greater than 1. So an equation sometimes it has multiple solutions, but the ones we're exploring in this class, like the 2x equals 4, only has one solution. Think about inequalities, though. They have multiple solutions. We know if x is true, if x is 2, this is a true statement. We know if x is 3, this is a true statement. If x is 1, that's not a true statement because 1 is not greater than 1. We know that if x is 0, that is a false statement as well. So just like I was saying earlier, algebra is we're really concerned about finding truth. We're really concerned about establishing truth in certain statements. And this is an inequality. And that's just the bare bones of what it is. This is probably the most simple example. And this is mainly what we're going to be talking about today in this particular lecture. So I think some of these topics are best illustrated with examples. So let's go ahead, go to page 231 in the book. We're going to be talking our way through some of these example problems. I see problem 5.26. Manute is taller than Michael. Michael is taller than Muggsy. Is Manute taller than Muggsy? So I want to maybe just type this up real quick. Manute is taller than Michael. Michael is taller than Muggsy. Is Manute taller than Muggsy? So this is really what we're trying to figure out. And if we had numbers, things would be pretty easy. For example, if we knew that Manute was maybe 5'3", and Michael was maybe a bit shorter, maybe 4'9", and that Muggsy could be, for example, maybe 4'8". It'd be pretty easy, but we don't have values. They don't give us any exact values for their heights. They just tell us that one thing is bigger than another and a third thing is bigger than the second thing. So there is still a way to answer the question, though, without numbers.
I think I know the answer.
All right, sure. How do you figure this one out?
Okay. Hold on. Okay, so it says Manute is bigger than Michael, right? Mm-hmm. And Michael's bigger than Muggsy. So maybe you can...
So let's maybe use an inequality to show this.
Okay.
Manute's height is greater than Michael's height.
And then Michael's height is greater than Mugsy's height.
Exactly. So we have two inequalities. Is there a way we could combine these and make them into just one?
Yeah, you can just do Manute is greater than Mugsy.
Exactly. But we still have Michael in there, though. Notice how Michael appears twice. Michael is less than a Manute, and Michael is also greater than Mugsy. So what actually we can do is we can take this Mugsy, move it up, and then just make it into one inequality. So that's one of the most common things we're going to be doing in this section, combining inequalities to make one inequality with multiple expressions. So kind of like with equations, we were able to create an equation with multiple expressions. We can do the same thing with inequalities. We can make bigger inequalities as a combination of smaller inequalities and as a combination of statements as well in expressions. So I think we've pretty much gone over all of this problem, everything in this problem as much as we need to. Let's go on to the next one. Bill Gates has more money than Warren Buffett. If they each win a $100 million lottery, then will Bill Gates still have more money than Warren Buffett? What if they each give $100 million to the Art of Problem Solving Foundation? Then who will have more money? So the amount of money that Bill Gates has is higher than the amount of money that Warren Buffett has. I wonder if that's still true. I'm not sure. I do know that Jeff Bezos has more money than both of those, but that's not part of this problem. I think he's the richest man in the world at the moment, Jeff Bezos.
Yeah, he has 168 billion or something.
Wow, I wish I had close to that amount. I might actually be able to pay off my student loans. So we know that Bill Gates has more money than Warren Buffett. We're discussing a scenario that they both win a $100 million lottery. So we know that just from our algebraic tools, that can be described as an addition problem. I'm going to use maybe just abbreviations. Bill Gates, the amount of money he has plus $100 million. And we want to discuss if this is still true. We know that this is a true statement. We want to discuss if the bottom one is also going to be true. So we have Warren Buffett, which is also going to be increased by a cool 100 million. So what do you guys think? Do you guys think if we add 100 million to both of these, is this still going to be a true statement?
Yeah, I think so.
Yes, because
Absolutely.
if Bill Gates has the same money, more money than Warren Buffett, if you just add them up, it's not gonna be the same numbers, but it's just gonna be the same.
Exactly. And I really like number lines. When I was first learning this topic all those decades ago, I thought number lines were a really good way to understand the concept. So $0 would be right here. This is the absolute least amount of money anybody can have, excluding debt, of course, but that's too depressing of a topic to even discuss here. I want to maybe put Bill Gates right here. Warren Buffett might just be slightly behind him. And I'm probably going to be somewhere down here. My net worth is probably going to be sufficiently lower, but we know that they have the same distance apart. We know Bill Gates is greater than Warren Buffett. So we're discussing adding the same amount of money to both of their accounts. And we can probably do something like this. I like arrows to explain this topic. So we're adding an amount of money to Bill Gates, his net worth, and we end up somewhere right here. So we're going to add the exact same amount to Warren Buffett's net worth. And that would take his net worth right around here. This is Bill Gates' new net worth. This is Warren Buffett's new net worth. So see how they still have the same difference between them. Before this lottery, they had a difference of, I don't know, we'll just maybe make this a difference of $D. Notice how they still have the same difference between them. And that's only because they inherited the same amount of money. They were awarded the same amount. So if they were awarded different amounts, this isn't necessarily true. But because we know that they both inherited the same amount, this relation is still going to be true. So we know it's true that when we add the same amount to both sides, if the original statement is true, then the second statement is definitely going to be true also. Now let's talk about maybe a different scenario. Let's talk about spending money. Let's say that maybe Bill Gates donates $500 million to maybe $500,000 to charity. So we know Bill Gates has more money than Warren Buffett. Let's say that they both donate $500,000 to charity. And we know that whenever we're deducting money, that is a subtraction problem. So they're both donating $500,000 to charity. So expression A is true. What do you guys think about expression B? Do we have enough information to tell if B is also true? So we know that if we add the same amount of money to both sides, it preserves the truth. It's still going to be a true statement. But what if we subtract the same amount of money from both sides? Do you guys have any thoughts on that? Do you guys have any thoughts on whether this is true or false?
It's gonna be. It's gonna be the same.
I think Bill Gates is still gonna have more.
Exactly, because we're deducting the same amount from both sides, and it doesn't matter if we're increasing or decreasing. If we're changing them by the same amount, then the truth is going to be maintained. It's still going to be a true statement.
Yeah, but either way, he had more money, like more money before.
Yep, exactly.
He subtracted 500.
Yep. But not only did he have more money before, he has more money after as well, because they're deducting the same amount.
Yeah.
Now let's talk about multiplying two values by the same amount. So let's go down to problem 5.28. In this problem, we investigate what happens when we multiply both sides of the inequality by a positive number. So they tell us to suppose that x is greater than y. Must we always have 3x is greater than 3y? Here, I think I'll type it. So what do you guys think about this? Is 3x always guaranteed to be greater than 3y?
No, it's not true. They're the same. It's equal. They're both equal.
Well, we know that they can't be equal because we know that x always has to be greater than y. That's what this symbol tells us. If we had a little line underneath, then yeah, sometimes they could be equal. But for this problem, x can only be greater than y.
Yeah,
but is it true for 3x and 3y?
I think it's true.
Yep, I think so too. Do you think it's true for all of them though? What if one of them is 0? What if we have y is 0, and maybe x is, let's just say 4. So let's say we have 4 is greater than 0, and we multiply them both by 3. Yep, absolutely. We just have another true statement. Now let's maybe consider negatives as well. Let's say y is negative 10. Let's say x is 1. x is greater than y. 1 is greater than -10. So then we can see that 3x is still absolutely going to be greater than 3y. So yep, this is absolutely true. It's going to be true no matter what. Negative numbers, fractions, doesn't matter. It's always going to be true. Now, let's modify this a little bit. Let's ask ourselves, is it also true if we have 2/3 x and 2/3 y?
Oh, wait, hold on. I have a question.
Sure.
Can you hear any music from my speaker?
No, I don't hear any music at all.
All right, because someone is having a birthday party, like our neighbors. And the music that I hear is kind of loud, so.
Did they invite all of us?
No, we're just friends.
Maybe it's from yours.
I'm sad that I wasn't invited to the birthday party, but it's all right. I'll move on with my life. So we know that it's always true that if we multiply x by 3 and we multiply y by 3, this is a true statement. So we're trying to figure out if the same thing applies if we multiply the numbers by a fraction. If we multiply the numbers by 2/3. What do you guys think about that one? Do you think it's true if we multiply both of these by 2/3?
Well, I think 2/3 x is going to be greater because x is greater than y, right?
Yes.
So if it was 2/3 x, x would be a greater number than 2/3 y.
Yep. You'll find that no matter what number we multiply this by, it should always give us a true statement. It doesn't matter if it's a whole number or a fraction, it's always going to be true. And then part C is saying that, is it always going to be true if we have the following? If we have ax is greater than ay, and then a is any positive number. Is this always true? And the answer is yes. It doesn't matter if a is a whole number or a fraction. And well, obviously if a is 0, that's no longer going to be a true statement because we have a 0 is not greater than 0. This is false. So we see that this is true only if a is a positive number, only if a is greater than 0. Doesn't matter if it's a fraction though. It could be a whole number or a fraction that's greater than 0. And this will always be true. And there are special circumstances that occur when we do the same thing for negative numbers. And I don't know if we're going to be talking about that in this particular section, but there are different circumstances for dealing with negatives. Oh, I think the next problem deals with that. So we're on the next page. We're on page 232. In this problem, we investigate what happens when we multiply both sides of an inequality by a negative number. Suppose that x is greater than y.
You're kind of lagging.
I wonder why. Am I lagging to anybody else as well? Yep, I'm getting a message on my screen that says my connection is unstable.
Maybe you should rejoin.
Well, it won't be easy for me to do that because I'd have to kick all of you guys out because I'm the host. I can't just leave a meeting and come back. When I leave the meeting, everything goes. Here, I think I might just type something up. All right, well, no matter what these connection issues are, I think I have no choice but to just do my best and continue no matter what. I don't really have too many options at my disposal right now. But the good news is this lecture is being recorded, so you'll have access to it. You'll be able to view it as many times as you'd like, and you'll be able to replay things if you'd like to, and hopefully the video won't be laggy. Hopefully everything will be crystal clear and not laggy at all. So we're discussing the fact that x is greater than y, and they're asking us if negative 2x is greater, or is negative 2y greater? So it looks like some people are having a bit of trouble joining us. I think it's just due to my own network connection being really poor at the moment and having some thunderstorms in my area. So my connection has been not very good. So I'm just recording this at the moment so that even for those who are not able to join the class right now, they'll be able to view the lecture and they'll be able to see the examples and review the topics when they have time to view them. So at the moment, we're trying to decide if negative 2x is greater than negative 2y, or if negative 2y is greater than negative 2x, based on the fact that x is greater than y. So the way we might want to approach this is with a number line. Sure.
Can you hear me? Oh,
yeah, I can.
Okay, wait, it's kind of lagging.
Here, if you have questions, type them into the chat, please.
Is this 4.5?
Nope, this is 5.5.
Oh yeah, 5.5. Wait, yeah, 5.5. Sorry, I was mistaken.
So interesting things happen when we multiply an inequality by a negative number. So x is greater than y, but let's not talk about negative 2x and negative 2y. Jacob, do you have a question? I see you raised your hand.
I have to leave and join on a different device. Can I please do that real quick?
Oh yeah, no problem. So we're talking about a special case where we multiply both of these by a negative number. So let's say, I'll maybe just want to introduce this as an example. Let's say x is 2 and y is 1.
Wait, why do we have to like how do we know that x is 2 and y is 1?
Oh, we don't know for sure. I'm just coming up with random examples. This isn't really connected to the problem at all. So
I don't need to write it down, right?
All right, sure. Yeah, please write it down.
Okay, so what if we like put x as 3 and y as 2?
That would also work.
Oh, okay, well, this is just an example, okay.
Yep. X is 2 and y is 1 would give us a true statement, and x is 3 and y is 2 would also give us a true statement.
Oh, so we basically had to find like a true statement, like something that fits inside.
Yep, exactly. There are infinitely many true statements. This is just one out of infinite true statements we can create. 2 is greater than 1. So the big question to you right now is what happens if we multiply them both by negative? What if we make both of these negative? So if we make both of these numbers negative, do we still get a true statement? Let's find out. So let's say instead of x is 2 and y is 1, let's say x is negative 2. Let's say y is negative 1. So is this a true statement or not? Let's see if we can figure this out. Well, we have x is greater than y. So substituting our numbers in, we get this. Now, this right here is a true statement. But is this true, though, is the real question.
Oh, well, if it's not true, we're gonna try to like refine the number, right?
Well, before we even do that, we want to figure out if it's true or not. So what do you guys think? Is -2 greater than -1? Shout it out if you know it. Well, we can use a number line to help us decide. So for the first one, we have 2 here, 1 there. So 2 is to the right of 1. So 2
Oh,
is
wait, hold on.
definitely greater than 1.
Oh, it's not going to be a true statement.
Exactly. So looking at the number line, we have -1 right here, -2 right here. So because -1 is to the right of -2, that tells us that -1 is greater than -2. So -2 is less than -1 for the same reason why 1 is less than 2. So this is not a true statement. This is a false statement.
So we have to find another number.
Not necessarily. There's something easier we want to do to make this true. All we need to do is flip the sign. So instead of writing 2 is greater than or equal to -1, we're going to flip the sign and make it 2 is less than -1. I think I said greater than or equal to before. That was not right. I meant to just say this is a false statement. -2 greater than -1 is false. So we flip the sign, and now it's true. This right here is a true statement.
Wait, so why do we have to flip the sign?
Because if we don't flip the sign, Daniel, we have a false statement. If we have, oh, hang on a second, we had this.
Whoa.
Like I said at the beginning of the lecture, algebra is about truth. It's about finding values that make equations and expressions and inequalities true.
Oh.
So the one we're
Okay.
given is false. So we have to flip the sign to make it true.
So we just flip it. If it's like not equal, we just flip it always, right?
If we multiply both numbers by a negative, then yes.
So we flip it every time when we multiply by a negative.
Yep, multiply or divide.
Multiply or divide when we.
Here, I'll write this down. It's really good to have this in your notes.
Oh, what? So let me write this down.
All right, so this is one of the most defining characteristics that we're going to be learning about in this chapter, in the section on inequalities. So please write this down. Please write all of it down, and please ask any questions if you have them. Now is the best possible time to ask questions about any of this. So there are 4 of us. We have Daniel, Jacob, Rabjot, and Adam. Do any of you guys have any questions at all on inequalities? Now would be the best time to ask.
So I have one question.
Sure.
So when you said hold on, let me write this down. So when you said if it's a negative one that has negative numbers, we just flip it.
Yep, we always flip the sign whenever we multiply or divide by a negative. So for example, in this problem, we had this to begin with, but then we flipped it because we multiplied by a negative. We changed less than into greater than.
Okay. Like we always do this, right?
Always whenever we multiply or divide by a negative. If we multiply by a positive, no, we do not. But if we multiply or divide by a negative, yes, we do. And I want to maybe.
Do a positive one?
Yeah, exactly. I will. But before that, I want to add that to the notes. We must always flip the sign whenever we multiply by a negative number or divide by a negative number. Something that we always have to do. Otherwise, we won't have a true statement.
Must always flip the inequality.
So greater than always turns into less than, and less than always turns into greater than, whenever we multiply or divide by a negative.
Okay, let me write this down.
So like I said, we're going to be doing some more examples in the last 15 minutes or so in this class. Do you guys have any questions on inequalities at all?
I just said, well, can we do some positive ones?
Yeah, definitely. But I want to make sure that you guys don't have any questions and that you guys have all of these copied down before we continue.
I'm just copying down the last thing.
All right, great. All right, let me know when you have this copied.
Oh, I have it copied.
All right. Are you guys all okay if I erase this? Speak now or forever hold your peace. So let's talk about an example. So let's say we have A is greater than B. So I want to give a value of A, and I want you guys to come up with a value of B. Oh, it looks like Miriam is able to rejoin us right now. So let's say we have this expression. Let's say, hi Miriam, welcome back. Glad you could rejoin us. Let's say we have the following. Let's say that I just make A equal to 10. So we have this expression now. So I'd like for Daniel to give me a value of B that would make this true. So any value of B, Daniel, that would make this inequality
5?
a true statement. Yep, exactly.
Well, you can make it 5.
And now I want you to give me a value of B that would make it false.
Well, 15?
Yep, that's a good one. 11 would also work, 12 would also work, 5 billion would also work.
I just picked like random numbers.
It makes sense. Yep, that's true. And then this one below is false. Now, Miriam, you missed what happens whenever we multiply inequalities by negative numbers, but don't worry. I'm going to be posting this lecture on YouTube later on. So you'll be able to review these topics.
I have a question.
All right.
What about the normal inequalities ones?
This is normal.
Oh, okay.
What
Are
do you
there,
mean?
like, any more types?
Yeah, there are, but I'm not sure if we're going to be getting into these today in particular. I was just telling Miriam that this lecture will be on YouTube later on this evening so that you'll be able to review things at your leisure. You'll be able to see the things you missed out on. So now we know that A and B are both positive. So now let's review the thing we just talked about. Let's review making them negative numbers.
Wait, I didn't copy that part down. Can I go back? Copy that down.
All right.
So I have a question. So is this just a separate example or is this a problem?
This is just a separate example I just came up with.
Okay, let me copy this down.
All right, let me know when you have it copied.
Okay. Okay, I have it down.
So now we are going to review the topic of multiplying both by negative numbers. So let's say we have this time B is greater than A. So let's just maybe use some particular values to use in this example. So let's say maybe B is 2. Let's say A is 1.
So
We know this is
I have a question.
okay.
So is this like a greater question, like which is greater or something?
No, we already know that B is greater than A. We already have that information right there.
Okay, so yeah.
So B is 2, A is 1. So together, if we plug these in, if we plug in 2 for B, plug in 1 for A, this generates a true statement. So we're just reviewing the topic of multiplying or dividing things by a negative number. So what happens if we multiply them both by negative 1? So let's say instead of B is greater than A, we'll have negative B is greater than negative A. So I want to keep the same values. I still want B to be 2. I still want A to be 1. So we want to substitute them in just like we did in the example above. A is 1. B is 2. So we have negative 2 is greater than or equal to negative 1.
So why is, I don't know what negative means. Like, what do you mean by the negative part?
So we're multiplying a number by negative 1. So instead of B, we have negative B. Instead of A, we have negative A. That's all it means.
Okay, so we changed it to negatives, right?
Yes, we changed them both into negatives.
So why do we have to change them into negatives?
Because we're going to explore if this gives us a true statement or if it gives us a false statement.
Okay.
So we have negative 2 is greater than negative 1. So if we look at a number line, we can tell if this is true or false. 0 is right here. Negative 1 is right here. Negative 2 is right here. Negative 3 might be right there. So we're exploring whether or not negative 2 is greater than negative 1. We can see by the number line that this is false. Negative 1 is greater than -2. So this is false. -b greater than -a is a false statement.
So I just don't get one part.
All right.
So I just don't get why we have to change it to negative, because I thought it was like a positive question.
Well, we don't have to. I'm just giving you a counter example. I'm giving you the positive version to show that the positive version is true. Sorry? Sorry, could you repeat that? Oh. So
What?
we know that b is greater than a is a true statement, in that we just found out that if we multiply them both by a negative number, it turns into a false statement. So this is the biggest thing I want to emphasize in today's lesson, that whenever we make numbers negative,
He had to leave the class. Justin had to leave the class 10 times because where he lives, I don't know. I think he lives in Florida.
sorry, could you repeat that? Could you type that into the chat, actually? All right, well, it seems like my internet might be lagging a little bit more, so we're actually going to call it a day a few minutes early. I know we still have 4 minutes left in the class, but I want to just maybe leave it at this. This is the most important thing to take away from this lesson, that if we have a true statement and we multiply them both by a negative number, it turns into a false statement. So we must flip the sign. We must make this -b is less than -a, and this, of course, is a true statement.
So so we have to flip it again.
We always have to flip the sign when we multiply by a negative or divide by a negative. So that's what I was trying to show in this example. You're asking why we have to make it negative, and the reason why is because I just want to show what we have to do to turn it from a false statement into a true statement.
Okay, I have just one question.
Okay.
So I just don't get, why did we make the positives into a negative?
Well, we don't have to. I was just showing what happens when we do that. I just want you to understand that whenever we do that, it makes a false statement and that we have to flip the sign. So we don't necessarily have to make them negative. I just want to show you what happens when we do.
Oh, so this problem depends on like making it negative, right?
Yep, exactly. Making it negative and then showing what must be done to turn it into a true statement.
Okay, I see. Get it. What if we don't like can you like do just this quickly part that, or what if we didn't make it like negative?
So we already have that example right here. B is, oh, hang on a second. This is exactly what you're asking about. B is greater than A. So we have a positive number, another positive number. So this whole thing is true then. So that's what you're asking, right? An example with positive numbers that's true. So that would be this one right here. B is greater than A is true if we have positive numbers.
So that's it. That's it. So what is actually the real problem ask for?
So this isn't exactly a problem. I'm just showing you guys what happens when we make both numbers negative. This isn't like an example problem from the book. I'm just using an example to illustrate this fact that I put in the box. The fact that we must flip the sign to make it.
So the earlier problem that we did, that was like a problem, right?
Yes.
Okay.
The one with Warren Buffett, that one was definitely a problem from the book.
Okay. Wait, no, I mean the -2x or -2y. Was that one a problem?
Yep, that one came from the book.
Okay.
That was from page 232 in the book.
Okay. I get it. I see.
All right, well, that's all we're going to be covering today. I'm going to be posting this lecture later this afternoon on YouTube. So if you guys want to maybe review this topic a little bit more, you'll have a chance to do it by watching the video. And that's it for today. I'll see you guys tomorrow. Have a good one.
I have something to say.
All right.
So we don't have any homework today, right?